Hello, Ms. Toshner. Today I'm going to be doing problem number 42 for my week 2 videos on chapter 4. And after this, I'm going to be doing problem number 43 as well. So let's get started off by writing our equation. E to the 3x minus 4 equals 6. Okay, so let's just take note of a few things here. So we see this e to the 3x. And what we're trying to do with this problem is simplify into terms of ln. So, or x equals ln. So, essentially what we're going to do here first is we're going to use PEMDAS to isolate the e to the 3x. And then I believe that we can use natural log to solve for x. And we just need to simplify there. We don't actually need to find the exact solution. So, let's get started. So we're going to add 4 to both sides here. So 5e to the 3x equals 10. 6 plus 4 is 10. And then we're gonna divide both sides by 5. So e to the 3x equals 2. So now is where we use some of the knowledge that we've been learning through this week and a little bit in algebra too. So if we can remember correctly, log base a of x equals y when a to the y equals x. So since e So this is basically the formula of how to solve for exponents. But since we have a base of e, we would instead use ln, natural log. And the natural log is the same as a regular log. Just the only difference is that it has an implied base of e. So that's what we're going to use for this question because we are also told to simplify in terms of natural log. So the rules of log and natural log are very, very similar. They're almost exactly the same, except for the base being different. So ln x equals y when e to the y equals x. So we can essentially so this is in the same form as this. So our current simplified version is in the same form as this, and we want to simplify in terms of natural log. So what we're going to do here is we're going to convert it into the form of natural log. So e is our e variable, is our e. It's a not variable, it's a constant, it's Euler's number. Then y equals 3x, and x just equals 2. So we're going to use these numbers. So ln which has an implied base of e. So it's essentially the same as log of e. So we're going to use ln, having that implied base, of x, which is 2, equals 3x. And so now we're just going to simplify it in terms of x. Like I think I've been saying throughout, simplify in terms of natural log. I mean in terms of x, my bad. But we're just going to divide both sides by 3. And x equals natural log of 2 over 3. And this is our final answer. And so just to clarify a few things, so basically just walk through the steps once again. So what we did here is we just algebraically solved, got to this form right here, and used our natural log rules, which state that ln um, or log e of x equals y when e to the y equals x. And we identified our e, y, x, and essentially just substituted it into here. And this gave us our final answer. And this gave us ln of 2 equals 3x. And we just divided both sides by 3. Got x equals natural log of 2 over 3. Okay, so now we're going to move on to question number 43. So we're going to find the exact solution for 2e to the 5x minus 2 minus 9 equals negative 56. And so already here, I'm kind of noticing something that could be off here. I'm just gonna go ahead and solve the problem, and then I'll wait a little bit before I come to conclusions. So 2e to the 5x minus 2 equals 47, negative 47, and we're gonna divide both sides by 2. And so one very important rule about e, e raised to anything can never equal a negative number. So as we can see here, is raised to a number and it's equaling a negative. So that's going to hint that there's going to be no solution for this problem. And so another way we could figure this out is just by using the natural log rule. So ln, we can just take them from up here, ln of x equals y, when e to the y equals x. So if we were to use this, so our e is going to be e, our y is going to be 5x minus 2, and our x is going to be negative 47 over 2. So if we were to take the natural log of this, we would get ln of negative 47 over 2 equals 5x minus 2. And so what we can notice here is that our argument is negative. So another thing that you can never have is a negative argument, which is also another detail that hints that the answer is definitely no solution. So just to run through this one more time, e to anything can never have a negative answer. And this is because when we take the natural log of that, it's going to give us a negative argument, and no logarithm can ever have a negative argument. All right, thank you for watching.